Hello and welcome back to the Carbon Nanotube Intro to Houdini mini-series, or the Carbon Nanotube tutorial as I like to call it. This is part 4, so if you've missed the first few parts, there's a link to part 1 up in the pop-up and also in the video description. But if you already have some familiarity with Houdini and you specifically want to learn about animation, keyframe animation, which is what we're going to be talking about today, you can just join us with this video. So let's jump into Houdini. To review, last time we finished our carbon nanotube model. I'll put a link to the starting file in the video description so you can follow along with me from where I am here. So last time we used some math to create a hexagon grid and roll it into a tube. And then we reused our atom and stick generator from part 2 to get our straight nanotube. And then we used a path deform to deform it along a specific curve. In this lesson, we'll look at how we can grow the nanotube along the curve. So we'll look at how keyframe animation works in Houdini, which is not quite like some other applications that you might have experienced. So before we get to the actual animation, I thought it would be good for performance reasons to create a kind of proxy that's going to perform better than our actual geometry here, because this network has to calculate the positions and deform thousands of atoms and bonds. So to create a proxy for this carbon nanotube, I'm going to start with this curve here, and I'm going to drop down a null, and that's just going to be a bookmark here, and we're going to call it the final curve, so that we know that the actual curve that we're using for the nanotube is the same curve that we're using for our proxy. And we're going to split it out here. So we're going to create a polywire. And you should be familiar with polywire from the previous bond creation. And we put the blue flag on here. It's kind of hard to tell because it might be super thin, but it doesn't look like anything's happened. And the reason that has happened is because, if you remember again from a previous part, we need a polygon input. And if we look up at our curve, we're using type NURBS. So NURBS isn't going to work with polywire. But what we can do is we can use a resample node, which does the conversion to a polygon curve. And it also allows us to put more points along it. So if we kind of highlight that, if we click on the point view, it's going to have a huge number of points. So I don't want that many points for our proxy. That would be way overkill. So in the length, I'm going to put something like 4. And now we've got a much more reasonable, it's still maintaining the shape of the curve, but a more reasonable number of points. And then if we go back to our polywire, now we should be able to see, again, it's going to be super thin. So let's bump up the wire radius here. And we want to match our carbon nanotube just so it looks nice. So we'll put the template flag by holding down E and dragging over our out deformed nanotube node. And we want something like, is it 4? Something like 4 in the wire radius. And we'll increase the divisions a little bit. You can do something like 8 or 12. Or again, this is just a very rough proxy, but we want it to kind of match the shape of our nanotube. So that looks good. And this is going to have way, way fewer points and polygons than our final result. It's going to be a lot faster to compute. So that when we're doing our animation, we get close to real-time performance or real-time performance. So we'll drop down a null and I'll call this our curve proxy. Or we could even call it, it's more accurate to say it would be our nanotube proxy. And if we wanted to, so that we can easily switch between our full nanotube and our proxy, I'm going to turn off the template flag so we know what we're looking at here. What we can do is we can use our a new node called a switch node. Now a switch node is pretty cool and it's very versatile. And what it does is it has, just like the merge node, let's show our merge node here. So it doesn't have 1 or 2 inputs. It's got as many inputs as you'd like to stick into it. And so the switch node is the same, except instead of merging them all together, it just chooses which input you want. So you can select the input. It's an integer value from 0 to whatever. So if we put this one in here and this one in here, and if we put our display flag on here, when the input is 0, it's choosing from this path. So whatever's coming in here. And you can see that the other one is dotted, which means it's not sort of active. And then if we go 1, then we're switching to the proxy. So that's great. So we've got a little proxy switch here. And switches are great. You can even animate them if you want to have a certain input for part of your time or part of your animation, then switch to another input for another time. They're good for, you know, creating variations. They're good for proxies. They're good for a lot of different things. And we can put a final null down here as just kind of our final result. Out, final nanotube. This is going to be our master final output here. So let's look at animating the growth of this proxy. And if we're doing the animation up here, which is what we're going to be doing, then that's going to propagate to our path deform, and the final result is going to be the same as our proxy. So we'll see what that looks like. So the way I'm going to do this is after the curve node, I'm going to put down a node called carve. And what carve does is it, I mean, you can see immediately what's happened here because we've got a default value of taking off a quarter. So the carve node cuts or trims surfaces, curves, polygons, and it does so based on a U coordinate. And by default, the U coordinate from this NURBS curve goes from 0 at the beginning to 1 at the end. So it's, by default, it's chopping off the first quarter of the U coordinate. So if we go up here, you can see that it's cutting off more and more. And if we go all the way to 1, there's nothing left. But we don't want to chop off that side of it. We want to chop off the top of it. So I'm going to uncheck the first U and I'm going to check the second U. And now you can see that, hey, look at that. That's kind of the behavior that we want. So let's just make sure that this is working with our actual nanotube. So I'm going to go back to 0 for the switch so that we're choosing the full deformed nanotube. And I'll come back to our carve and let's just make sure that this is working the way that we want. So this is kind of, it is working the way that we want. I want the cap to stay at the top. It's not chopping off the cap, and I'll explain why that's the case in a second here. But as we're going, it's a little bit hard to see, but if I just kind of do a small amount here, you can see that it's kind of growing from the bottom and new atoms and bonds are put down at the bottom. So why is that? You might expect that if we're carving off the top of it, it would chop the top of the nanotube. And that's because in our path deform, we've actually reversed the curve. So the end is at the base and the beginning or the start is up at the top. And with the map and deform, the end behavior we've set to clip. So those combination of parameters have set it up so that when we have this second U being carved, it actually works the way that we want. Remember, it's not carving the result of the path deform, it's carving just this curve, right? And that's going to go in here. It's going to flip whatever's here, and then it's going to chop off the end. The bottom line is it works. But you can see that as I'm adjusting this here, I'm getting like 5, 10 frames per second. So if we're animating this and we want to just see the result of it in the viewport, nice and quick, then we might want to use the proxy. So I'll do that. I'll view the final result. And if you look here, we're getting well more than 24 frames per second, which is the speed of the animation that we're going to probably be using. Let's look at how to create animation then. So what we want to do is we basically want to animate this parameter, right? We want to animate it from a small value over time to a larger value. So we have down here at the bottom, and actually I'm going to jump myself over to the right side of the screen so that we can see these interface elements a little bit better. We've got our time slider down here going from frame 1 to frame 300 or 1000 or whatever the default is. It might be 240. So we're actually going to change that to 240. And now actually I'm on the wrong side here. So we're going to put in 240 here. And you can see that there's this range slider here. Gonna have to keep jumping back and forth. Okay, so we've got this range slider here, which shows the part of the kind of the broader timeline that we're looking at. So we're going from 1 to 1000, and the range slider is going from 1 to 240. Fine. Can you see all of that? I should have an option where I'm up here somewhere. We also have play, pause, rewind. That's the basic stuff. What I've done is I've mapped those two little forward and back buttons on my mouse, and I highly recommend doing that if you ever work with animation and you have a mouse that has the little forward and back. Here, let's see. These guys right here, forward and back, forward and back. You can, with the software that comes with the mouse, you can remap those buttons to whatever you like, and I map those to the shortcuts for play, which is up arrow, and control up arrow, which is rewind. So basically I can just hit the mouse buttons. Play, pause, play, pause, play, pause, rewind, play, rewind, play. So whether you're in After Effects or Maya, Fusion, Houdini, whatever, I like to have those play, pause, rewind hotkeys mapped to my buttons. Makes things very nice. If you notice the play slider playing real fast, it might be that this button is unchecked. So that's just going to go zipping as fast as it possibly can calculate. But this one limits it to a maximum of whatever frame rate you have in your animation. And you can set that in the global animation options, which is this little button down here. And we have it at 24 frames per second. So this real-time toggle limits your animation to 24 frames per second, which is good. Sometimes you want it playing as fast as it possibly can, but most of the time if I'm doing animation, I kind of want to see a real sense of it. Now, beware that if you have a really complicated scene or network, it might be less than that. And there's a way that we can actually check whether that's happening or not. I have this little frames per second heads up display here. If I hit D in the viewport, we can come over to guides, and under additional information, we can check draw time FPS. And what that's going to do is it's going to have this little frames per second display, and right now nothing's really happening. It's calculating at more than 120 frames per second. But if I hit play, I had to click in the viewport to get it to refresh a little bit. But if I rewind and hit play, this green says, you're all good. It's 24 frames per second. We're playing at the proper speed. But if I go back to the proxy switch and go back to 0, it's not actually having to calculate anything new on every frame. And that's why that's going to be playing at 24 frames per second. But if this was animated, it would be less than that. Okay, so let's get to the actual animation, then where this will all make a little bit more sense. So let's make sure that we're on frame 1. We're going to rewind here, make sure we're on frame 1. And we're going to key this value, whatever small value, 0.04, something like that. The way that we can key this value is either right click, we can go keyframes, set keyframe, or there's a hotkey or shortcut, which is nice to use, and that's Alt left mouse button. So we can Alt left mouse click in here, or choose it from the pop-up menu there. And now we see this is green, and there's a little green tick mark on the timeline. If we don't have the carve selected, then it's going to disappear from the timeline. So it's only really the selected nodes and their animated parameters that are going to show up in the timeline. And if we move the time slider forward, we can see that this changes to a light blue color. And that's to indicate that this is an animated channel. It's an animated parameter, but there isn't a keyframe on the current time that you're on. On frame 136, there's no keyframe. So I'm going to go to frame 72, which is 3 seconds in our 24 frames per second animation. And I'm going to increase this value up to 0.6 or something like that. And when I let go, you'll notice that this changes to kind of a what is that, yellow-green, kind of a yucky color. And that's to tell you that you have changed the value. This is a value that's not part of the original animation, but you haven't keyed it yet. So heads up, if you change the time, it's going to snap back and you're going to lose that value because you haven't actually baked it into a keyframe yet. So we're going to move up to 0.6, and this time we're going to do Alt left, and that color goes back to, resolves to a nice happy green color, and we have that animation there. So now if we look and scrub between these, or if we rewind and play, now we can see that this tube is growing and we have keyframe animation. Fantastic. So there is a way to have the keys automatically get set when you change the value. So if we're changing the value on frame 24 and you get this color, there's this circle button with a key, which I'm sitting on top of. So I'm going to come over to the side. So this circle button with the key, that also matches the color. It says you've changed the value, but you haven't added a keyframe. So you can click on that and it turns green, and we've set the key there. I'm going to undo that, and I'm going to scrub so we lose our value here. There's another option here that's auto key changes, and you see that this has this little auto text on top of it. And now what happens is if we change this value, it's going to automatically have a key set on there. So we've got this sort of little pause in the middle. We can make it shrink again, and it's going to automatically set a key here. Shrink and grow again. I personally don't like having the auto key on here because it's really easy to accidentally set keyframes that you weren't intending to. I like to know for sure when I'm actually setting those values. So I like to have that off. There's another feature of this that's really important to understand. So remember, if we're on a frame that doesn't actually have a key on it yet, and we change the value and then change the frame, that value gets lost. But if we're on a frame that already does have a key set on it, like frame 24, you can see it's green, and we change the value, that's going to be preserved. That's going to be saved. And that's because we have auto commit changes on. And I do like to leave that on because when I'm on a frame that has a key, often I know that I'm actually wanting to change the value. But if you're accidentally changing those values and you didn't want to commit to those, what you can do is you can turn this auto commit off and you get a little checkbox here. So if I go to a frame that has the key here, increase it here, I'm going to get that yellowish color again, and I'm going to have to actually manually set that key for those changes to be preserved. So there's a couple ways to approach it. You can have it automatically set keys whenever you make a change, or as the default scenario, you can have it automatically commit the changes if you're on a frame that already has a key, or you can turn that off so that you actually have to manually set the key no matter what frame you're on. So pretty quickly, if we're going to be wanting to manipulate these keys, we're going to be wanting to use the animation editor where we can see a visual representation of the keys and the animation. So let's open that up so we can go up here to split pane top bottom, alt close brackets. And instead of the scene view, I'm going to choose the animation editor. And now we can see that we've got a handful of keys here and curves in between them. That's animation. But there's more going on here than you might think. And if you want to manipulate these keys and curves, you're going to have to understand how they work in Houdini. It doesn't function, a little foreshadowing pun, like other applications. And I think it's important enough to spend a little bit of time on so you don't get hung up for a chunk of time like I did with the animation editor. So seeing the results of our animation changes is going to be a little bit easier to see if we do something like a rolling wheel instead of a growing nanotube. So I'm actually going to move away from the nanotube for a few minutes and create a torus here. I'll put the display flag on it, frame it up here. I'm going to put this in the Z-axis like so. And just for a little bit of fun, so this is kind of a nice rolling wheel, I'm going to set up a couple of expressions, which we talked about in the previous video, so that our torus is going to roll as it moves along. First, we're going to have it sitting on the ground plane. So our center Y is going to be a function of our radius 1 plus, copy parameter, our radius 2. There we go. So the sum of these two radii is going to be letting our torus sit on the ground plane. And our rotate Z, which is the rolling action, is going to be a little bit of a complicated expression. I'm just going to put it in here. It's going to be 360 degrees times the translate X channel. That's the one that we're going to animate, moving along in the X axis, divided by 2 times pi, which is 3.1416-ish, times the sum of those two radii, the distance from the center of the torus to the outer edge. And now if we move our torus, it's going to be rolling. It's a little hard to see, so we're going to go in here and uncheck U wrap and maybe do something like 350 so that there's a little bit of a gap in our wheel so that we can actually see what's happening when it's rolling along. Now you can see that it's actually rolling backwards, so we're just going to put a negative there. There we go. And now our wheel is rolling along. All right, and let's look at our front view here. There we go. So we're just looking at this view, and our torus can roll along. Super. Okay, so I'm just going to set up our range slider to something a little bit tighter, so from maybe 1 to 72. And in our parameter view, I'm going to click on the center and rotate. So instead of seeing the expressions, we're just seeing the final result. And on frame 1, make sure we're rewound all the way to the beginning. I'm going to set a key for a value of 0. So Alt left mouse button on that. And then we're going to go frame maybe 48 and set a value of 10. And remember, after we set the value, we have to key the value as well. So we'll rewind and we'll see, yep, our torus just kind of rolls along. Super. So let's take a closer look at our animation editor. We can navigate this in a similar way to the network view. Hold down space and right mouse button to zoom in and out, and we can do those independently in the sort of the time axis and in the value axis. So we can kind of frame up how we like, and space middle mouse button or space left mouse button to kind of pan around and sort of frame that up. We can also hit H, and that's going to home the view or frame all of our animation curves. So you'll notice on the left here we have a channel list. This is a list of our animated channels. It doesn't show them all, just the ones that have keyframe animation or the ones that we add to this list. It doesn't include the ones that just have the expression on here by default. So the animation editor is smart enough to know that once you have animation on a parameter or channel, then we may want to manipulate it. So we could add some animation on, for example, the radius. So I'm going to rewind, set a key 0.5 here, and then maybe bring this not all the way down to 0, but maybe 0.1. And now you can see that by keying this radius channel, we also have radius Y in our channel list. So if we rewind, we can see that our wheel's getting skinnier as it goes. Maybe it's losing air or something. So by default, they're both selected. So by selected, I mean that there's a little dot here and the curves show up in the animation editor. But we could click over here to deselect everything and the curves disappear, or we could select one or the other and work on them independently. So we can control click or shift click to select both of them or kind of drag over them. And if we just select the radius Y and hit H here, you can see that the view kind of frames up so we get the full view of that curve. And then if we selected both of them and hit H, then it's going to frame up so we can get a view of all of them. A little bit of terminology. So these are selected channels if they've got that dot beside them and they're showing up. But if they're just in the channel list, whether or not they're selected, they're called scoped. So that's to distinguish them from other parameters that aren't showing up in the channel list. So these are scoped channels. So I'm not going to get into that distinction too much, but it's worth noting that some tools and operations in Houdini work on all of the scoped channels, and some of them work on just the selected channels, for example. And you can even add non-animated channels like this radius by going to channels and add to channel list or shift middle mouse button. And so that's in here. So you could add animation to it or work with it in whatever you wanted. And you can also right click channels and do remove from channel list. So this is a list you can work with, but let's work with the curves themselves. Okay, so we're just going to isolate the rolling animation, which is our center X keys. So this animation curve has these little dots, these keys, and we can select a key by just clicking on it, this one or this one. And you can see that when it's selected, we have this tangent handle. So this should look pretty familiar if you've ever worked in another program that has an animation editor, but things will get a little weird, I promise. But first, the nice stuff. So if we click on a key, it's very easy to change the key values. We can click on the middle and drag up and down, and that's going to change the value of the key. So instead of starting at 0, we can start at 5-ish, something like that. And now it's going a shorter distance in the same amount of time. We can also put a specific value in here, in this value field. We can do 8, and that's going an even shorter distance. And of course you can change the value in the parameter pane as well, change it down to 4. But the difference is in the animation editor, you can change the value even if you're not on that frame. So if we did it here, it would be changing this first key, but we could change this here or change it up to 10, how it was before. And we can change multiple values if we're dragging over all of the keys here on our radius Y. We could change this dash 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 to 0.3, and a dash 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 just means there's different values selected. Okay, back on the center X, to change the time value, the frame that that key is on, we can click on this vertical bar and drag left and right. So now we're going from 0 to 10, or from, change it back to 0 to 10 in a very short period of time. And we could select all of them, and by dragging left and right, we can change the whole animation. So I really like this, having two different handles to change the two different things, clicking on the key itself to change the value and clicking on the bar to change the frame. That makes it really nice to have the control and to know that you're changing what you're wanting to change and not accidentally changing both of them at the same time, which you can do by holding down Control and clicking and moving that key. But I like to have those separated. Another nice feature, which you may have noticed, is you have this little ghost of a curve, and that's to show you what if I reset that by just changing my selection a little bit, the ghosted curve shows you what your curve looked like before you made a change. And that's called a snapshot, and you can change some various things here. You can clear the snapshots, you can swap the active curve and the snapshot and do various things. But that's kind of a nice little preview to show you how you've manipulated that animation curve. So let's change this back to frame 1 and to frame 48. Now let's talk about tangent handles, which control the acceleration of the animation. You can see this acceleration field down here. So let's click on the dot at the end of the tangent handle, and we can drag this out. And if we wanted to constrain it just to that same line, we could hold Control and drag it out. And let's click on this one and Control drag this one out. And now we haven't changed the key values at all, but we've changed the shape of the curve. And now what happens is we have this very exaggerated ease in and ease out motion. Starts off slow, gets very quick, and then finish off slow again. If you wanted to change just the slope without changing the acceleration, you can click on the line of the tangent itself, sort of drag that up and down, so you get something like this. It goes back a little bit and then zooms forward, maybe a little bit of anticipation. And if you want to change both the acceleration and the slope, you can just click and drag this tangent handle as well. So we could do something like, I don't know, something like that. Fast, and then slow, and then fast. What if you just want to have a straight animation with no acceleration at all, what we call a linear animation curve? A lot of effects are linear, including the growth of the carbon nanotube probably. We probably don't want acceleration on that. How can we do that? Well, we can kind of eyeball the tangent so it looks kind of straight like that. Or we could select everything in this curve, Control A, and click this button here, this straight button, and boom, we have a straight line between them. And now no acceleration, no ease in, no ease out, bonk. And everything seems fine, but I'm gonna hide this animation editor just for a sec here. Let's say we want to adjust our animation. Instead of going 10 units, we probably just want it to go, let's say 4 units. So now it's going from 0 to 4 in this linear path. Why did it slow down and then speed up again? I thought we had a linear animation. Well, let's bring back the animation editor and see what happened here. Why did the curve change? Did our tangent handles change? Actually, the problem is that our tangent handles didn't change. If we go to this value and come back up to a value of 10, you can see that we have our linear animation again. So how to solve that? Well, we could remember to select everything and click this straight button again, and then we've got our linear animation. But to do that for every single change, that seems a little bit annoying, and we might forget. And I could be misremembering, but I feel like in Maya, when you have something like this where you have set the key tangents to be linear, it remembers that state, and when you make changes to the curve, they stay this linear curve. But in Houdini, there is a better way. But first we need to understand how Houdini stores the type of curve that it uses to interpolate between keys. So to explain this, let's make a third key on frame 72. I'll just make it a value of, say, 5. And I'm going to set this 48 frame key back to, whoops. That's what I get for changing it in the parameter view and not here. Let's make sure that we're just selecting this key, changing it to 10, and that's 0. Okay, space H to kind of frame up. By default, most of the handles are hidden, but we can show the tangent handles on all of the keys by clicking on this button here, show all handles. Right now we just have it as show selected handles. So when you select a key, it shows the tangent handles, but I'm going to show them all so we can see what's happening here. So remember, when we click on the vertical bar, we can change the frame. And if we click on the key itself, we can change the value. And if we click on this line of the tangent, we can change the slope. And if we click on the end of the tangent handle, we can change the acceleration. But what if we click on the curve itself? Then we can change the function. And this function is the answer to all of Houdini's gotchas when it comes to animation. Well, some of them anyway. You see, Houdini stores the type of animation curve in the segment, which is the name for a piece of animation curve between two keys. Well, what does that mean? Well, let's try changing the function from Bezier to constant. Okay, so now we have a constant value between this frame and this frame, and then we have Bezier animation after that. So if we select this part of the segment, we have the constant function. This segment, we have Bezier function. And we can actually see that in the parameter pane. Remember when we click on the parameter, we can change from seeing the final value to the underlying expression. Well, that's the same with animation curves. Here we can see we're using a constant function or a constant expression. And then if we go past here, now we've switched to a Bezier function. Bezier, constant, constant, Bezier. Okay, so each segment has its own function, and the default function when you're doing keyframe animation is Bezier, and you can change that in the animation settings if you so wish. Control comma, animation, default function, rotation function, Bezier, Bezier. Good stuff. Bezier, if you're not familiar, is the kind of function that's similar to like a pen tool in Photoshop or Illustrator, where you have points and you have tangent handles that you can click and drag and change the shape of the curve however you want. Notice that the constant key doesn't have any tangent handles. You can't change any tangent to constant. It's just a constant value. So we could change this segment from constant to linear, which is the second one down. And now we have a linear curve here. Straight animation, and then it does some funky stuff. So you notice that this key itself is kind of a hybrid. It has a tangent handle on this side, but it doesn't have a linear tangent handle on the other side. There's no tangent handles for a linear function. So it's kind of easy to get tripped up here if you don't understand what's happening underneath. But we know that we have a linear function for this segment and a Bezier function for this segment. And also, now if we change this value up and down, we don't have any tangent handles to kind of mess us up. It's going to stay linear no matter what. So no matter how we change these values, we have a straight line between them. So that's where a linear function is useful. If we know that we want just straight animation, no ease in, no ease out, just straight from one number to another number, then we may want to use a linear function as opposed to a Bezier function. So you can just kind of reset the curve a little bit back to sort of how it was. So I think this is where I, at least, was getting confused initially. So let's say I'm thinking in terms of tangent handles. Let's say I marquee select this key with the tangent handles and say I want it to be linear. But why did these keys change? I only wanted this key to change. And remember, it's not because I was selecting the tangent handles. It's because when I was marquee selecting, I was selecting both animation segments. And when I change the animation segment, all of it changes back to linear. It's the segment that stores the function. Well, fine. Well, what if I want just this key? Just undoing here. What if I want just this key to have kind of a bounce feeling and the other ones to be, say, flat? Well, in that case, we do have to keep everything as Bezier functions, because remember, Bezier functions can have tangent handles, but linear cannot. So then what we can do is adjust the slopes for these tangents. What's the slope? The slope is the line part of the tangent handles. So we can select both of these, right click, and do set selected slopes to linear. Remember, set selected slopes to linear, not segments. And what's happening here is now the tangent handles are linear shapes, but the underlying functions are still Bezier. So we've got ease in, sort of bounce, and then slow down again. And we can set the selected slopes to automatic, which in this case is the same as 0 or flat. You could change these to 0, and you can also hit the 0 button. And remember, you have to have at least a slope selected. You can have more stuff selected, which is kind of where some confusion can happen. But at the very least, you need to have this slope selected. You can hit 8 to go linear, equals to go automatic, or 0 to go flat, which in this case is the same as flat. But let's say we had another key here. I can alt left mouse button on the curve itself to add a key, change the value to something like this. And then you can see that by default, we're in automatic. So this key here, if we select the slopes here, it could be linear or flat by hitting 0 or equals, makes it automatic. These 8 and 0 and equals keys don't work if you have just the key or just the acceleration handle or just these ones. It has to be at least be the slope, but usually I just marquee select over everything so I know that I have the slopes selected. You may have noticed that when you have an automatic key by hitting equals, the key is diamond shaped and otherwise it's square shaped. And that's just an indicator to show that you have an automatic, oops, see I just selected the key itself, not the slopes. If I hit equals with the slope selected, then we have this key telling us that it has automatic tangents and the other ones are manual. If they're automatic and you change the value, you'll notice that the tangent handles get automatically updated from sort of flat to sloping. But if you have the slope set to flat or any other kind of manual setting, then it doesn't matter how you change them, they're always going to stay as you put them. And that's just a visual indicator of the type of tangents you have associated with that particular key. If you're trying to do linear tangents by selecting the slopes and hitting 8 and they're staying all in a line instead of this kind of bounce shape, then you may have to click this button, which is untie handles, and you get a dotted line instead of a solid line. And now you can move these tangent handles independently. And if you select them both and hit 8, then they'll go into linear. Or you can always tie them back together and they'll stay in line. But there's a different set of buttons for working with segments that look like they might do similar things. And if we're working with segments, we have to make sure that we have a segment, one or more segments selected. And then we can click the first one, which is constant. And if we're working with segments, that means we're changing the function. So we've changed the function to constant. So far, so good. We're going to skip over this one and we're going to go to this one, which is cubic. And cubic looks like it might be similar to Bezier, except it doesn't have tangent handles. And this last one is Bezier handles. So back to our familiar Bezier handles. Great. And we've got Bezier function. Let's take a look at this button. We've clicked on it before. If we click on it, does it change it to a linear function? No, it doesn't. It leaves it as Bezier, but it changes the shape of the connected handles to look like a linear shape. And now we can see why this is kind of a problematic, confusing button, because it didn't change the function to linear. It left it at Bezier, but it changed the shape of the tangent handles so that they appear linear. So when you change the key, it doesn't stay linear. This is essentially doing the same thing as selecting multiple slopes and hitting the 8 key. Why this is with the segment functions, I'm not 100% sure. At least they had the courtesy to call it straight instead of linear, but I still think this is, at the very least, it's a little bit inconsistent. Anyways, the point is, if you're at least aware of what the buttons are doing, whether they're working on slopes or segments or whatever, then you shouldn't get tripped up. Incidentally, there is a way to set the tangent handles so that they'll behave like a linear function without actually changing the function from Bezier. And that is, if you select the tangent, the end of the tangent handle here, you've got the acceleration. If you set the acceleration to 0, that tangent handle will essentially disappear. And if we do the same to this other side, now we still have a Bezier function, but the curve behaves like a linear function. And that's because the tangent handle is infinitely small. That might be useful. Okay, I've made a real hash of this animation curve. Let's clean this up a bit. I'm going to delete that key. All right, so we're going to set this to 0. We're going to set our tangent handle. Let's just do it, come over here and set it to automatic to start with so that we can kind of manipulate it ourselves. That's one way. If you can't grab it because you had set the acceleration to 0, you can just marquee select over it and hit equals, and then you'll get it. And then on frame 48, let's come to a value of 10. All right, fine. Another source of accidental confusion that I want to flag. Let's say we're on frame 48 and we want to change this value from 10 till 3. And let's say we want to do it in the parameter pane. So we just come up here and hit 3 and we get the value changed to 3. But what's happened here? It doesn't animate properly anymore. It looks like we've somehow set a constant function. What's happened here? So let's look carefully at the parameter pane and see what's actually happened. So here we have a Bezier function, and then on frame 48, our function is 3. That's not the value, that's the function. And if you've ever graphed y equals 3 on a graphing calculator, well, you get a shape that looks pretty much like that. And if we had accidentally clicked this back to the value view and tried to change it to 5, it's just going to keep switching back to 3 and completely mess us up. So the way to fix it is to make sure that we're looking at the expression or the function, or we could select the curve itself, the segment, and change it back to Bezier. And then we can come here, make sure that we're looking at the value, and then change that to 3. And that's what we actually wanted to change. So that's another thing that's not so weird once you have a handle, pardon the pun, on what's actually going on with the segments and the keys. One final source of problems, if you happen to run into it, let's say that we've accidentally unchecked this button, which I'll explain in a minute, and we're changing the time value from here. And let's say we want to change on frame 37 our value to 5. And we'll key that because it doesn't seem to be keyed. But what's going on here? There's a key. Is it on frame 38? No, we wanted that to be 5. What's going on here? So what we actually have, and I'm just going to go back to our show only selected handles. What we have is a key that's not on frame 37, it's not on frame 38, it's in between frames. Yes, keys can live on decimal or fractional frames in between whole numbers. And for obvious reasons, that can cause a lot of problems. So to make sure to avoid that, what you can do is make sure that this is checked on, snap moved keys to the nearest frame. We can get rid of these keys because we didn't actually want them. We wanted just to move this one. And you'll notice that this is actually a white key, and that's to indicate that it's not on a whole number, whereas the other keys are red for this curve. So now if we select it, and then it'll snap to the nearest frame. So just something to be aware of if you accidentally get keys in between, sitting in between frames. It's not too hard to fix those. I think that covers most of what you really need to know in order to do keyframe animation in Houdini. Obviously, there's quite a few more options and tools, but these are the big problem areas that I've run into. And I think if you have at least a working understanding of how the tangent, handles, and the segment functions work, then you'll be able to do most of what you want when animating. Okay, let's get back to our carbon nanotube. So let's just view our space 1 to get back to our perspective view. And let's look at where we had our animation. And you'll notice that this node has a little green clock beside it, and all of the ones below it have a green clock. And that's the network saying that this is a time-dependent node. So right now this animation curve is all Bezier functions with some kind of ease out and ease in, and we don't really want that. So I'm going to delete this key here. Actually delete that key here. So we're kind of just going from frame 0 or frame 1 to frame 48. Now, I don't know that much about carbon nanotube growth kinetics, but my understanding is that it works by, if we just go back to our full carbon nanotube, a gas like ethylene or something like that, which has carbon atoms, and those carbon atoms get deposited at the base by reacting with a catalyst. And assuming that the gas isn't a limiting factor, in other words, we're not sort of using up all of the gas as it goes along, I think that this carbon nanotube growth should be fairly linear. I did actually find a paper showing linear growth at something like 0.3 or 0.4 nanometers per second, depending on the surface area of the catalyst. Now, I don't personally care much about the real-time growth aspect, but it is good to know that it should be a linear growth. So remember, there's a few ways to do that. Come back up to my carve, but the simplest way that I'm going to do is just select the animation curve and go linear. So now we have linear growth. So we've been able to animate the growth here. A lot of talking to do one fairly simple thing, but I hope your understanding about animation has been deepened here in Houdini. There is one little issue here that I want to take a look at, and if we just drag our value down to a fairly small, so that over the course of this, it's only growing a little bit. If you look at the base here, you'll notice that as it grows, this path to form is trimming off either the atom spheres or the bond sticks. So we're not showing the whole carbon deposition process in our animation, but I do want one thing to be accurate, and that's that we shouldn't have these extra little bond sticks sticking out if there's no atoms on the other side of them. So in the next lesson, among other things, we're going to take a look at how we can trim off those extra bonds. So that involves a teeny tiny little bit of code, which actually opens up a whole world of possibilities in Houdini. So I hope you don't miss that one. Thank you so much for joining me for another part of this carbon nanotube tutorial. Once again, if you learned a few things, thumbs up and comments are very much appreciated. And if you know somebody who might be interested in this series, please feel free to share it with them. If part 5 is published, you can join me in the next video by clicking up over here. And remember to subscribe to Making Biocinematics so you don't miss the next parts in the series. Thank you again for watching right to the end, and I hope to be able to teach you some more things soon. Bye.